So, go ahead and take these seats. It doesn't matter which one you sit in. So a little bit of the history here. So we, again, we kicked off a symposium in 2019 as a ride-along event with these global summits. We did a regional symposium along with the regional summit. And then we started to gain some interest and some momentum behind some of the topics we were investigating in symposium. And we were asked by the OCP Incubation Committee, I think it's called something different now, steering committee now, but the old incubation committee, to investigate doing year-long work streams around this. So continue building collaborative R&D work streams across the industry. We are on we've graduated one. We are graduating another one, not to give away our announcements here. We're evaluating 2 more. So now this has gone from, in the amount of 5 years, going from being 10 papers, 10 topics. Now we do poster session, now we do technology demonstration, and we have these 3 workstream leaders that are leading fantastic work that is impacting our industry. And then if you all know Manoj Wadekar, he was our first successful graduation of an R&D workstream into an OCP sub-project. So just to think about that a little bit, when we kick off one of these efforts, an FTI workstream, we have a couple criteria. One is industry engagement. So can we get 3 to 5 committed members of the industry saying, yes, this is interesting to us, and yes, we want to partner on this. As the chair, what I drive then is what are the outcomes across a 3 to 5 year period that would impact and be of interest to OCP members, so the industry that we would be serving here in R&D. Once we have that, we then look for an ROI equation. Are we going to spend a little bit? Are we going to get more? Do we expect to get more impact than the energy we would put into this as a community? Or is this just something cool to be investigating? So without further ado, I would like to discuss the 3 work streams and what's happening this year. So I would like to introduce Sammy Nachimuthu. He leads our cloud service model workstream. You want to tell them who you are and what you do for your day job?
Yeah, I'm Sammy Nachimuthu. I'm from Intel. Day-to-day, I work on firmware and server projects. On the cloud service model, but we are trying to accomplish is, if you are deploying system at scale, what type of problems you will be running into? How do we create a community around that to kind of solve those problems? So today, if you look at each OCP projects, it's trying to address the individual items, and now we are trying to go at scale. Then when you start looking into the problems, like if you're running into deploying firmware at scale, or if you're having errors at scale, how are you going to root cause and connect the problem from one system to other and root cause the problems, things like that we are doing the work.
Yeah.
Do you want to go more? Or just
please, go ahead.
Yeah. So what we have done is we created a white paper called
let's wait on the accomplishments.
Okay.
We're going to get to there.
Sure. Okay.
So generally, to think of their work stream, as technologies are entering our industry, we know when CXL Gen whatever is coming through. We know when a PCIe Gen whatever is coming through. They want to make sure that the open source community has the tools available to do that hardware management, essentially. Is that a good way to characterize?
Right.
So that's a good way to think of CSM. Next up, we have Weifeng Zhang. He is leading our AI hardware software co-design workstream. Would you like to introduce yourself in your day job and just overview the workstream?
Sure. Good morning, everyone. My name is Weifeng from Lightelligence. I'm leading this AI hardware software co-design workstream. And I'm currently a chief architect and VP of software for the Lightelligence, and responsible to build a system architecture and also software ecosystem to enable optical computing and optical interconnect. And this AI co-design work group mainly is targeting build efficiency and the performance for AI infra. So we'll have more details maybe following questions.
Yes, let's hold the details for now. And lastly, but not least, for sure, our newest work stream. We launched this year. Around this time last year, we made the announcement, right? This is Seok Ki. I'm sorry, I'm working on that pronunciation even though I'm Korean. And he leads our data-centric computing workstream. Can you overview the workstream and talk about your day job?
Yeah. Good morning, I'm Seok Ki, Vice President of Memory Solutions Lab, Samsung. I'm leading the data-centric computing work stream. And the main focus of the data-centric work stream is we have sort of the fragmented accelerator market right now, including GPU. So there are many new kind of accelerator, how we can actually connect this device together in the focus of the data, meaning that data placement and data movement. So workstream is mostly focusing on the evangelizing the concept and come up with the seamless way to connect this device through software and hardware effort.
Wonderful. Now we'd like to get into the work stream. If we can talk a little bit about what this year has been like, Yang, starting with you. Can you talk about how we curated this, like the membership, involvement, major achievements, and where are you at today?
Yeah, this work stream started last year when we just finished the first year, and one of the main contributor of work stream is mostly the memory vendor and the storage vendor, and some of them are a cloud vendor as well. But the issue we discussed past year is how we can actually come up with the solution to address the problem. The first thing is actually educate people we have problem. We come up with many different solutions, but that solution solve some problem, but actually create new problem as well. So evangelizing that is first thing. So through that kind of discussion, we are writing a white paper to actually formulate the problem and what is possible solution we can address the problem. So the writing the white paper is one accomplishment, and also the Samsung actually donate a kind of platform to evaluate and explore the problem. So the two item is the major one, and currently 12 companies actually joined the work stream and have a bi-weekly meeting and have a quite active discussion right now.
Yeah, and let's talk about this. This work stream didn't start out as data-centric computing. So let's talk a little bit about that history, because I think it leads on to some of the broader topics you're going to talk about in the future later.
Yeah, so initially start with computational storage work stream, but it mostly focusing on the storage device. But actually topic we're going to cover in this work stream is more broader than that because there are many other accelerator like memory-based accelerator and storage-based accelerator and network-based accelerator. Basically, all the passive device in the past become an active device. So how we can actually provide a view, the holistic view and the kind of consistent view across all devices, and from user's perspective, how they can use them in a seamless way based on the data characteristic, location, and a format, that kind of the characteristics.
Yeah, so the way I kind of tracked this as we were building this was we started with a thesis, which was around there's some promise around the idea of tying memory and compute together. Obviously, with AI applications and large-scale applications, there's some trade-off that we're doing there. And then as we got into the work, we started to understand it was less about the platform and more about the capability. And so Yang, as the chair, really quickly steered us towards, no, this is actually about the capability of just thinking of data-centric architectures in computing, which I think is the right direction for this work stream. So that's what happens in R&D. We start with a thesis, we start developing, and then we start actually narrowing in on where we're headed. So that's a great example, I think, of how the type of work we do unfolds when we don't necessarily see it at the first.
Actually, great summary and kind of the great vision from you. So thank you for sharing the your opinion, and actually I can incorporate your vision into the work stream as well.
We'll write it down. All right, Weifeng, let's talk about the history, because you stepped in after I chaired this AI hardware software co-design work stream. And what I'll say before he gets there, I'll fill in my history. We kicked this off knowing that AI, this was probably 2020, we kicked this one off, knowing it was a very large-scale effort. So think about proprietary algorithms at the company level. Okay, that's not going to be open sourced. Think about the silicon level and down. Okay, that's not going to be open sourced. What can we collaborate on in an industry? And then there's so much work happening kind of tangential and around AI. How do we do a collaborative R&D work stream that's actually impactful? So when we started looking at co-design, basically we were navigating through that, and year one was just a map to say, here's the space, here's what it is and what it isn't, and here are the opportunities for our industry to collaborate. thank God, Weifeng came along at the end of that white paper year 1 and said, okay, I think I know where to take this. And he offered to chair us. So now I'll give it to you. You want to pick it up from there and talk about your achievements since then and where we're at today?
Sure. Thanks, Allan, for the history. Actually, I didn't know much before I took over this position. So basically, I started from last March, about 1.5 years ago. So the main achievement from this work group so far is we got a white paper called Polymorphic Architecture for Future AI Applications. As Allan mentioned, the AI is so popular and hot, and we certainly want to focusing on the performance and efficiency, how to build an efficient AI infrastructure. So the key idea behind this white paper is really inspired by 2 questions. The first one is, how do we build efficient architecture to scale with this fast evolving AI algorithm? The second one is, how do we take this advantage of a current architecture trend, let's say giving this near zero latencies. So we basically address these questions using this polymorphic architecture, so that on one hand, we can build like a flexible and also purpose-built architecture. For example, that with near zero latency, and we have a flexibility to partition and share and decompose all the resources, so that we can build efficient architecture for a current application, just as efficient as like ASIC accelerators. The second one is we want to take advantage of this architecture trend, for example, like heterogeneous computing and architecture disaggregation, and also composable memory, chiplets, and all this good stuff. So basically, with this polymorphic architecture, we are able to, build flexible and also purpose-built architecture at the same time, and we have a natural integration of all the current technologies. So we'll have more details in the afternoon breakdown sessions.
Excellent. And this paper is wonderful because I think you're right. We're talking about latency, which is performance-based. I think the big piece is the adaptability of the system architecture, because AI is about experimentation. So a lot of times, like the algorithm designers can't tell us exactly what they're experimenting on. They can talk about the space, they can talk about the parameters. They can't talk about much else, because they don't know until they start experimenting what they're going to learn through that. A polymorphic architecture, and the way it's laid out in the white paper, really starts to address that and starts to provide a solution towards how do we think of designing adaptable AI systems when we're investing a ton of money and a ton of engineering and time to build these 30,000 node systems, right? So where can we find this white paper? Where can the audience find this white paper today?
Yeah, currently the white paper already published in the OCP website. There was a documentation folder, and there was one, just search for maybe polymorphic architecture, OCP, as 3 keywords, and you should be able to point to that red link. Just search from Google, it's good enough.
And then the other way is, while you're here, you can talk to Weifeng and you can get his email address and connect with him. I'm sure that they could also use support in their workshop.
Yeah, also find me on the LinkedIn.
All right, Sammy, let's talk about CSM. Now we can talk about the achievements and let's talk about the graduation. Very exciting time.
Yeah, actually, we started 2.5 years back, I think February of...
Original work stream.
Right. So we talked about starting work stream, then we formed the work stream, and...
let's talk about the origins. What was the thesis? Because you were there from the start. What were we trying to solve?
So basically a lot of inputs for the OCP was that I think we need to have people looking at the problem of how do we deploy at scale, and what type of things that we need to put in place as OCP community, so that we can make use of all the work done by all the other projects and the community. And when we want to deploy the systems, we are running into a lot of scaling problems. Can we find out what are the problems we are running into, and can we figure out a way to create a community to address the problems, right? That was our origin, and then we started looking at the people who are interested in joining, and we got like Meta, Google, Microsoft, Intel, yes, obviously from representing that, and also later Samsung joined, and Dell is joined. So we are, kind of started talking about what type of problems we are having. Let us figure out what is the major problems we are running into, right? Then people kind of bring a lot of brainstorming sessions to kind of identify the problems. So we kind of immediately the one thing came out was, yes, we have data that we are collecting out of band through BMC, but we don't have a standardized mechanism on an in-band. People are using a lot of proprietary mechanisms. How do we go and standardize that on an in-band side? And also now you have a data from in-band and out-of-band for all the memories, errors, and all the errors happening. How are you going to correlate the data from one system to another system? Maybe if you take a particular memory vendor, I want to take all the errors from data center for that particular vendor and want to correlate and figure out where the which particular problem is or symptoms are causing the problems, right? Like that, like a lot of different brainstorming ideas came up, and we kind of chose a few things to carry forward. So what we have done is we started discussing, like we are meeting every week to discuss these problems and come up with a solution. So we identified the 3 areas we want to work on it. One is, how do you define a model to represent the telemetry at a data center scale level? And how do you correlate the data between the systems? We started using the rate trace and other things to represent that. And also we wanted to define the in-band management architecture similar to the BMC out-of-band. Then we spend a lot of time on what is the real life cycle going on in the data center. Once you identify the life cycle, you can really like point to those problems. And lately we are also looking into how do we use AI and ML for fleet management. Oh, yes. So three basic white paper in progress. One is ready to be published. It's in the legal need to go through that. Other 2, we are halfway through. We are writing the paper. We are trying to get it published soon.
Yeah, so an incredible amount of output in 1 year's time. In-band starting with telemetry data sharing. So there's a white paper there that's in final legal.
Correct.
We have the in-band management
Correct.
paper. It's like an architecture paper, essentially.
It's architecture, yes.
Yeah.
It's architecture using existing concepts, and how do you make it to be ready to be written and developed and deployed.
Yeah, and that one also is going through legal, but it's basically
not
written.
legal. We are not yet finalized.
Oh, we're still finalizing that white paper. And then let's talk a little bit about the last piece, the lifecycle management. So that to me is more of the roadmap of how to use this capability of cloud service model. Is that a good way to think of this?
You can think of what is happening, the life cycle in the data center. First, let us document it. Then we have a language for us to refer whatever we are saying, deployment, what we are meaning that, right?
Yeah.
Then we want to connect all the different OCP projects going on. What is the output produced by each project, and how are we consuming it?
How is this new standard coming
Right.
in, this new gen of whatever is coming in? When should your work stream be involved?
Right.
Yeah.
And also, like now, when we are talking through that, identify the gaps or opportunities where we can, as OCP, we can improve it, right?
Yeah. So this is a big collaboration with that steering committee, with the CTO, and then the announcement we have to make today, which is very exciting.
Super. Definitely, yes.
Go for it.
Okay. So what we are, given we are started producing white papers and a lot of collaborations going on, what we want to do is we want to promote the CSM work stream under Future Technology Initiative into hardware management as another work stream under the hardware management. Given, if you look at the fleet management, has a lot of hardware components in it that need to deal with it. So it's the right place where we can have a lot more synergies within the hardware management. There is hardware fault management going on. There is a lot of definitions going on in the hardware management. So we thought like it is a good place to be there.
Yep, so every year we're looking at these work streams. Particularly, I started the year with AI Codesign, kind of going to Weifeng saying, is this too hard of a space? Are we going to get anywhere here? And then he luckily steered it towards this incredible outcome, which is the polymorphic architecture white paper. And then we'll talk about where we're going to take it. With CSM, they had such incredible amount of output this year. that the steering committee came to us and said this belongs as an OCP project, sub-project somewhere, but we need to start evaluating the amount of stuff that they're talking about giving us this year as products coming out of an R&D work stream is no longer R&D. It's actually applicable to the product lines today. So that's an incredible thing. And let's talk a little bit about the delineation between OCP project, sub-project, and a work stream, which is what you all are landing as.
Right. So if you look at the project, it has a set of strict guidelines, say what is your goal, where you need to achieve, and what is your final output going to be. And if you are looking at a sub-project, you are really like taking a project and taking a particular part of the work and dividing and trying to get that things accomplished. Again, you have a strict goal of what you need to accomplish there. In the work stream, it has little flexibility where you can have a lot more broader topics there. And once you identify that specifically what you want to deliver, then you can even make it as a sub-project. But I think for us, still we are a lot more explorations going on. We would like to be in the workstream space so that we can have a little more flexibility in our deliverables there.
Yep. So if you'd like to be involved in that work of looking at cloud service model and how they're impacting the product lines, kind of being introduced to OCP, and then as we talk about the future, there's some very exciting things that they're working on. So please go talk to Sammy because you are going to be involved in leading that work stream.
Yeah, myself and Panos is going to do a co-lead. So thank you, Panos.
Excellent. All right. Let's talk individually within these work streams. So for CSM. I've talked to you a lot about the idea of AI agents. First of all, let's talk about how AI is relating to your work stream in general. Go ahead.
Yeah.
Sammy.
So if you look at, for example, memory errors coming into the devices, right? There is a lot of work going on. If you are running into particular memory error, what are the actions you can do? You can have correctable errors, uncorrectable errors. You can, even if you look at non-memory related errors, you can shut down the systems, right? But if you are able to predict the errors, then you can say offline the page and you can basically keep running the system. So if you are trying to predict, you could have a multiple different type of mechanism, right? You can run through all the data and go into the predictive mechanism. Or you can use AI to predict, hey, this particular page is going to go bad and I want to take it offline. Like that, if you really have a lot of data and telemetry, you have temperature, power, all kind of fluctuations going on. If you are able to look at all the data and you are able to correlate where the problems is going on, you can probably take some immediate action. So that is one example. So like that, there are a lot of examples where you can use AI to improve or increase the productivity there.
Excellent. And then obviously the AI co-design workstream is AI, so maybe I'll save a more specific question for you in just a second, or do you have any thoughts on how your work is impacting what OCP is doing around AI?
Sure. Yeah, from yesterday's presentation, everybody knows that AI algorithm, the models are changing so fast, and the model is big, getting bigger and bigger, and so is the data set. So, but in the traditional architecture, we know that we have to bring the data near to the computer engine so that we can do the actual processing. But this certainly takes a lot of time and energy. So in our case, then we want to, if we want to really build in the efficient architecture to deal with this like AI and the large language model, so basically we have to address like two types of questions. The first one is, how do we actually move the data efficiently and also trying to do like more compute for every single byte of data? So this needs a lot of breakthrough in the technology from architecture. On the second perspective, that because the AI algorithm is changing, so that how do we actually build this architecture to scalable with this AI algorithm? So on one hand, because like different AI application domains, they have basically different requirement from the memory bandwidth, capacity, latency, and the compute, and so on. So we basically have a kind of a divergence across the different AI application domains. At the same time, just because the algorithm is changing, so that we have divergence across the different generations of AI algorithms, same domain. So basically, we characterize this as like a two-dimensional evolution, and the temporary evolution means like across different generations, and the spatial divergence, that means across different AI domains. So we are building this polymorphic architecture to address these two types of questions. So I feel like this polymorphism is really like a paradigm shift from architecture design perspective. So polymorphism really enable us to do like a future-oriented and flexible architecture. And in certain sense, we actually emphasize more on a system level innovation over like macro architecture innovation.
Wonderful. And Yang, how about you? How does data-centric computing play with AI?
AI basically AI model is basically built on top of a huge amount of data, right? So data should be in the storage or memory, whatever processing unit you are using. So even in the GPU case, and when you process data, basically you have an issue of data the bandwidth and the latency issue, right? So basically, where you gonna process data, that is actually a question data-centric computing actually the focusing on. So traditional model, you have to move data, as Weifeng mentioned, to GPU core or CPU core. But question is, do you really need to move data? And if not, then why you are moving data? So you can do some operation in the memory, you can do some operation in the data. Basically, to achieve most efficient, energy efficient, power efficient computing, you have to decide where to process the data. So data-centric computing AI, especially large language model, does not require a lot of computing power. So moving data to just apply a few operation is waste of energy and very inefficient from system perspective. So AI is the kind of application from the domain-specific computing perspective, and the technology we have from memory and storage can address this problem very efficiently. So but the issue is that, okay, there are individual solutions, how we can actually solve the problem across different solutions to address the problem very energy efficient way. That is the main focus of data-centric computing, and the AI is a big application for that.
Wonderful. So Sammy, something I've been talking with you a lot about lately is how AI agents will play in firmware development. So can you talk to automation possibilities and when you could see those within the industry here? And then do you see a time when AI-generated firmware and device drivers could be deployed?
Yeah, that is a kind of interesting question. When we look at AI, right, first you need to train with a good amount of data. That means all the firmware development, all the specifications, all those things, and how do you kind of go from creating your hardware, and how do you start finding the problems and root causing the problem, and fine-tuning your architecture to finally like come up with a final architecture, right? So the firmware is not like you've done everything and you are going and writing the firmware. There's a lot of process involved in creating your hardware and getting the firmware ready. There is a lot more, development discussions going on in developing architecture, right? So once you really maturing to the level of getting the architecture, you are already getting your firmware ready. So that kind of mechanisms that you have to train the models, and you need to really able to come up with a mechanism to write it. So what I'm trying to say there is, in order to do a firmware development, if it is already matured architectures, it's probably much easier. But you already probably have a copy that you can copy and use it. But if you want to use AI to develop firmware drivers, it's going to take time. So you need to find a way to have enough data to train it and kind of create a firmware engineer model there.
So what I'm hearing from you is skepticism that we'll ever get there with a fully developed firmware from these AI agents. Okay, I love it. Please go talk to Sammy if you have a differing opinion, because I think I might. AI Codesign. When we talk polymorphic architectures, what opportunities for architecture evolution do you see with AI systems going forward? Because we're very compute-centric today, processor-centric today. So what do you see in the future as possibilities that could disrupt our industry?
Yes. The process-centric architecture essentially means you need to bring the data to the computer engine, right?
Well,
So,
for me, it starts with, when we think of an AI system, we start with teraflops. We start with the processor and what we can do there. We don't start with data positioning or with the application or anything like that.
yeah, right. So because AI has so special, right? Just because the data and the algorithms is huge. So there was certainly alternatives, trying to address this problem. And maybe that this is one of Yang's expertise, doing the data-centric computing. But from my perspective, I feel like basically there was a few approaches to address this problem. First one is basically you process the data at a spot. So that means, for example, like the process in memory or process in near memory, right? Those two can basically leverage in like memory properties or bring the computing logic near to memory bank, right? That's called like memory computing. But that's just an example for this processing at a spot. Another way to do it is basically you do data processing at a spot, but you can also do the processing on data transferring. That means like while you do the processing, when the data is on the fly, so you do the processing. So the one example is like optical computing. So basically the computer is done at the speed of light. So there's no actual overhead because the data is transferring anyway. So you do the processing at the same time. There's no overhead here. So basically, from these two perspectives, either do a processing on spot or do the processing on the fly. So I feel like this at least is some way to to look into this architecture perspective. But there's other ways like energy-centric processing. There was a lot of ideas floating around. So in general, I feel like this. Basically, our polymorphic architecture should be able to integrate this type of like a domain-specific acceleration, either memory-centric or other energy-centric processing architecture, so that we can build, trying to build efficient computing infrastructure for future AIs.
Wonderful. Okay. Yang, real quickly, you and I have had lots of discussions about where you can see this work stream and where you see the work going. I would love for you to just take like maybe 90 seconds and talk about some of your thoughts of starting with app design and then working backwards towards where do we position the data. And this is much broader than computational storage and much broader of a concept. So just go ahead and talk for like 90 seconds.
Yeah, so I'll give one example how this kind of concept can work, even though the Weifeng really mentioned about that. Let's do work with the Spark, the map reduce operation. So data start from the storage. So if the map operation is mapped to the storage device and do very basic operation, then you have a bunch of storage device and do the map operation. And then you need to do the shuffling and reduce operation. Shuffling operation basically go through the network, as I mentioned. When the data move, you can do the kind of sorting and the partition operation at the network level. And once the data landing on the phases, then you can do the reduce operation at the memory level, and you can use very simple operation like addition, multiplication. That kind of operation can be easily implemented in the memory device as well. So there are a bunch of different type of accelerator at a different level that can be actually coordinated together to solve the traditional problem more efficiently. Right now, how you solve the problem? Just the read data from the storage into memory, applies the conventional CPU, and send the data over the network, stored in the memory and storage, and do it again. That is how it works, but we can change how it can be done different way. Yeah.
Wonderful. So the central theme that I would love for you to take away is I believe that we're on the precipice of rethinking some of our architectural norms when we're designing these systems. So, okay, we are definitely past our time, but we're eating into my time, which is okay. So I would love 30 seconds from each of you on what you see the next 2 to 3 years of your work stream. 30 seconds, Sammy.
Yeah. So 2 or 3 things from the CSM cloud service model, right? The one big thing that we want to make sure that its life cycle is clearly like understood from a community what we want to contribute, right? Every data center operator, they know they have a life cycle, but we want to bring a a common understanding in OCP, and how do we use all the different project outputs that we can connect within the life cycle, and any new technology comes in, are they really understanding how it's going to be deployed at scale? Have we discussed this new technology? What are the problems that need to be addressed so that you have the building blocks in place before you deploy that new technology? The second thing is ML, AI, AML, there's a lot of use cases. How we, as a community, we can form a framework, then we can share the models that we want to go and define it. The third thing is always we have to go and find the new areas that need to be deployed at scale that we want to go and explore and bring the OCP together.
Wonderful. 30 seconds, Weifeng. What's the future of your work stream?
Yeah, currently we are working on the architecture definition and the simulation. So maybe in from next year or so, we start to look into like how to build like FPGA prototype and a software stack. And we also interested to go even further, bring this like memory pooling, resource pooling, so that we can enable a large scale polymorphism. So we do need a strong participation from community, like this composable architectures and memory, the system disaggregation, FPGA prototyping, software stack, and there was so much work need to be done. So we need all to participate in our work group. Thank you.
Yep, we have collaborations with RISC-V, open hardware group that we're exploring. We're talking about even possibly building a prototype if that's what the industry wants to do, so they can put our hands on this system and let people have access to it, this polymorphic architecture. So very exciting things happening. Yang, 30 seconds.
Okay, so the next 1 or 2 years, what the workstream is focusing on, actually, to demonstrate that this concept is working through the prototype and through the white paper, and to educate and evangelize the concept with the team member to the industry, and demonstrate it is actually working concept, not just theoretical thing.
Wonderful. Let's put our hands together and thank the workstream leaders.